So one of the main powers of a digital computer is the fact that it can do calculations and processes over and over again very quickly. So in order to instruct a digital computer to repeat things over and over again, we have some different methods. So let's see if I can spell this. So we want to accomplish repetition. So one way of doing this is iteration. Another way is recursion. I just want you to be aware that there's more than one way to accomplish having a computer repeat things over and over again. We're going to save recursion for CS2. So we'll be focusing on iteration. And in Python, we have two options for iteration. We have a while loop and we have the for loop. Essentially, a while loop can do everything we want it to do. A for is simply a very specialized while loop for the specific case of when we know how many times something is going to happen. If there's some way for us to know how many times the loop, exactly how many times the loop is going to run, we can use a shorthand kind of a loop, which is the for loop. But really, a while loop can do both cases when we have no way of predicting how many times a loop will run, as well as when we do have a way of predicting how many times a loop will run. So here we don't know, and here we do know. All right, so next let's talk about the components of a loop. So just like selection statements, loops are controlled by conditions. And we've talked about all the different ways that we can write conditions, but basically a loop is going to happen. So what we want to happen is we want to repeat as long as our condition is true. So every time the loop happens, the condition is going to be checked. If it's true, we enter the code in the loop again. If it's not true, we exit the loop. So there's essentially three parts to every loop. One, we have to set the condition. So there initially has to be some value to that condition, some true or false condition. We're going to check the loop. So we set up our loop to repeat as long as the condition is true. And then I actually want to put this in here. Inside of that loop, we have to have some way to update the condition. We have to have another way to put this is we have to be able to change the condition within that loop, or else we'll never be able to exit it. If there's no way inside the loop to ever change this condition, that means it's going to be true forever, and this is how you get an infinite loop, a loop that just keeps running over and over and over again. There's no way to exit it. Python keeps you from crashing. It's safe that way. Other languages are safe that way, but some languages are not safe that way. Other languages, if you have an infinite loop, it's actually going to take up all the space in your RAM, and it's going to crash your computer. Most development environments now have safeguards to keep your infinite loops from crashing your computer, but essentially, if you can't ever end an infinite loop, you have to basically be able to break out of that using some kind of a development system or something like that. So in other words, what I'm trying to say, very complicated, is that infinite loops are bad. We don't want infinite loops. We want ways for our loops to be able to end. So every loop, we need to set the condition. So this is every loop. Again, we're talking about iteration. Both our for loops and our while loops will have a setup of our condition before the loop runs. That condition is going to repeatedly be checked, whether it's a while loop or a for loop. As long as that condition is true, the code will be run inside of that loop. And inside of that loop, it's important to have some way to change that condition to avoid an infinite loop. Note that when you set that condition, if the initial set of the condition is false, the loop will never run at all. All right, so we've talked about our three parts of a loop, and we're going to shorthand these with set. We're talking about the condition. We're going to call the second step check. This is where we're repeatedly going to check the condition, and as long as it's true, we're going to run the loop. And then we're going to call this update. And again, we're talking about the condition. So all three of these apply to the condition that controls the loop. So let's take a look how this looks in a while loop in Python 3. All right, so let's say we have some sort of condition. We're going to start with x equal to 5. And so x is going to be our condition that controls our loop. And we're going to say something like while x is let's say greater than 0. All right, so as long x is greater than 0, so 5 is greater than 0, so the first time this loop runs, it's definitely going to happen. And then let's print x. And now we've got our set. So this is right here. We're setting our condition. Here is where we're checking our condition that controls our loop. Here's some code that happens. Now we have to have some way to update this condition. In this case, it's our x variable, or else we'll never get out of this loop. We're just going to keep printing 5 forever until our computer crashes. So we've got to be able to change our x. So let's say every time the loop runs, we're going to say x is equal to itself minus 1. So we're going to be counting it down essentially. All right, and a shorthand of this, x minus equals 1, that's sort of the Python shortcut. This means x minus equals 1 is the same thing. These are essentially equivalent. So you're going to see this shorthand throughout the book and in other Python code. This is just a shorthand for x equals x minus 1. Similarly, if I had x equals x plus 5, I could say x plus equals 5, and these two would essentially be the same thing. So here is our update of this code. Now what's going to happen when this code runs is that the first time it runs, x is going to be equal to 5. So we can trace this. Let's trace the value of x as we go through this code. The first time x is 5, and it is greater than 0, so x is going to print. So let's trace what happens on the screen. So this right here is the value of x. This is what's printing on our screen. So 5 is going to print on our screen. Now x is going to be equal to 5 minus 1, so x becomes 4, and we're going to come back up and check the value of x. So 4 is still greater than 0, so we're going to print 4 onto the screen, and now x is 4, so we're going to say let's store in x 4, the initial value of x minus 1, so now x is 3. We're going to come back up here. We're going to check 3 is still greater than 0. So we're going to print 3 to the screen. And now x is going to be 3 minus 1. So x's value is 2. And we're going to come up and check 2 is greater than 0. We're going to print 2 to the screen, and then we're going to again decrement x. So now x is equal to 2 minus 1, so x is 1. Come back up and check 1 is greater than 0. We're going to print 1 on the screen, and then we're going to again decrement by 1, so now x is 0. So we're going to come up here, 0 is not greater than 0. So now this condition is false, and now we leave the loop, and if we had some more code here, we would just continue on with the code. All right, so that was a while loop. So let's look at that same while loop as a for loop. All right, so we had x is equal to 5 while x is greater than 0. We're going to print x, and then x equals x minus 1. In this case, we can figure out exactly how many times the loop is going to run. It's always going to run and print 5, 4, 3, 2, and then 1. And then once x becomes 0, it is no longer going to run. So this is the special case of a while loop where we're able to make an equivalent for loop. And every loop still has to have our set, our check, and our update. So let me show you how the equivalent for loop to this code has the same elements. So again, this is our set. This is because our condition that we're checking is x. So here is where we're checking it, right in this while x is greater than 0. And then this x equals x minus 1, that's our update. So the equivalent for loop looks like this. For I in range from 0, and actually we want this to be Sorry, let me grab an eraser here. We're counting backwards. So we need this to be from 5 to 0, print X. So this code will do exactly the same thing as this while code. So let me explain what's going on here. So the range function creates a list for us, and actually I forgot something very important here that will mean this code won't run correctly. Because we're counting backwards, we need to include the step of -1. All right, so what happens is the range function creates us a list, and this here is the starting value. This here is one more or one less for counting backwards than the ending value, and this tells us the step. So in this case, we're going backwards by 1. We're decrementing by 1. If this was a plus, we'd be counting up by 1. So let me show you what this means. So this means our list value is going to be 5, and then you're going to take 1 from it, then 4, then take 1 from it, 3, then take 1 from that, 2, then take 1 from that, and 1, and we never make it to 0. So this stops the one before this right here. So we actually have to say we're going to 0, but it's going to stop at 1. And the reason why it does this is going to become a lot more clear once we start using for loops to process lists and strings. For now, it's just going to seem a little weird. It's important for you to remember this is always one more than where you're going to stop at. So then what happens is once this list is created, for I in, so I is going to be each value of this list one at a time. So the first time through the loop, and actually we don't want to print X, we want to print I. The first time through the loop, we're going to print 5. The next time through the loop, we're going to print 4. The next time through the loop, we're going to print 3, then 2, then 1, which is exactly what this code does right here. And we didn't have to call this I, we could call this X, and then we could call this X. That's absolutely fine. I, J, and K are often used as the counters, which is what we call this right here. It's the counting variable. In for loops, you'll see that pretty commonly in Java, C, C++ code. It's just a convention someone came up with a really long time ago. So in Python, you can use whatever you want. You'll see this the most often, using I, J, and K for counting variables. But let me show you where the set, check, and update are. All right, so the set is here, what we're starting at, right? X or I or whatever you want to call it is equal to 5. The check is right here. Here is our check. It says we want to stop before we get to 0 while X is greater than 0. And then the change or the update is right here in this step value. Just like X equals X minus 1, that's essentially what we're saying. X or I minus 1 each time through the loop. So these two pieces of code do exactly the same thing. You can see that 4 is a little bit neater, and 4 is just a nice little shortcut. It's going to be really handy when we do lists and strings. While loops are really good for when you've got maybe some sort of user input, and so the while loop is going to continue until the user does something in particular. We don't know how many times it's going to take for a particular user to give us the input that we're looking for. So we have no idea how many times that loop is going to take. But a while loop can actually be used anywhere that you would use a for loop. So this is just kind of a summary of iteration, for loops and while loops that we'll be using in this course, and we'll be seeing some more examples as we go along. Happy programming!